Okay, let's talk about p-values. So when we talk about a p-value, p simply stands for probability. And this is crucial for understanding and interpreting the results of your inferential statistics, which we'll be learning in the next unit. So a p-value is not the probability that your hypothesis is true. It's the probability of getting your data that you found, the results you got, or more extreme results, if the null hypothesis were true, if there were no relationship between the variables. So for example, a p-value of 0.04 does not mean there's a 96% chance your hypothesis is correct. It means that if there were no real effect between the variables, if the null hypothesis were true, you'd only see the results that you got that were that extreme 4% of the time by random chance. So statistical significance, this is another key point, does not equal practical significance. You can get a tiny p-value, which means that you have this high statistical significance, but it can actually still only mean a trivial effect between the means. Or say if you were comparing the means of two groups, you could have just a slight difference, but if you have enough people in your sample, you might still get a low p-value and achieve statistical significance. So it doesn't, and similarly, a high p-value doesn't prove that there's no effect. So if it's way above 0.05, it doesn't mean there's no effect. It just means there's not enough evidence. So you could still have quite a gap between groups, say, but it may not cross the 0.05 threshold to be below that so that you'd be able to say that it was statistically significant. So I know I say I'm talking about 0.05, which is the standard threshold used. It's called an alpha level. You pick a threshold that your p-value should be below to call something statistically significant. So why do we use 0.05? Just convention, right? It's a conventional, it's the most common in social science and education and psychology, psychological research. It's popularized by early statisticians to be a reasonable balance between type 1 and type 2 errors. But some fields, it's worth noting, do use stricter thresholds. They might use P has to be below 0.01 or even 0.001, such as in medicine or physics, where false positives can have a lot more serious consequences. And if you're reading a journal article, you'll often see like asterisks on findings that have a p-value below these thresholds. One asterisk usually means the p-value is below 0.05. Two asterisks mean it's below 0.01. Three asterisks mean it's below 0.001. Or another way of saying that is there's 95% confidence, 99% confidence, or 99.9% confidence that the results you got were not simply due to random chance. So when we talk about significance and non-significance, it's pretty simple then. The alpha level, the threshold you pick, usually P, the O5 level, if your p-value is below that, then you reject the null hypothesis. The null hypothesis says that the variables are not related. And so there's enough evidence to suggest that there is indeed an effect, that there is a relationship, a correlation between variable A and variable B. But if your p-value is above 0.05, then you fail to reject the null hypothesis. So it doesn't prove that there's no effect. There may be an effect. It's just that you don't have strong enough evidence to reject the null hypothesis. So we would say it's not statistically significant. But keep in mind, even though a lot of folks, when they're doing research, really want to find like statistically significant results, non-significant results are still important. Non-significance is just a statistical term. It doesn't mean it's not a significant finding or important. Non-significant results can still help refine theories. It can help prevent publication bias, where people are just hunting for statistically significant p-values and then they only publish on those, which increases the chance of an error. And it's a contribution to cumulative science. So sometimes, well, to use a metaphor, as a classic Sherlock Holmes tale where he realizes that indeed the intruder in the home was the owner because the dog did not bark, right? So if you think of statistical significance as the barking dog, well, sometimes the dog not barking is still an important finding. So, and it's worth noting because a lot of people will often, and they shouldn't, but they'll hunt for statistically significant findings and then publish those. And so that contributes in some ways to this problem of what we call p-hacking. P-hacking is where you manipulate your data or analysis methods to get a significant results. Maybe you run multiple tests, you're data mining, you're running variables against each other until you find the ones that are significant, and then you simply publish on those or write about those. Now, why is that a problem? It increases false positives. It leads to misleading conclusions. And it can waste resources because you don't necessarily know for sure that you can trust these results if people are just hunting for the combinations of variables that have statistically significant correlations. Because remember, we're talking about probability and confidence levels, right? So P equals zero 0.04. Probability at a 0.04 level means you're 96% confident that you got the results not due to random chance. But it doesn't mean you're 100% sure. And so if you're hunting for all of these statistically significant correlations, you're increasing the odds that at least some of them will actually have been in that 4% chance that you found those results just due to random chance. So it's something you want to avoid. You pre-select your hypothesis and the relationship you expect between variables based on some theoretical justification, right? Often this comes from the literature. Then you test that, then you report on that. And you report on all the analyses you do, not just those that produce significant results. So, of course, p-values are just one tool in statistical analysis. The context and the study design and whether the study can be replicated actually matter more than just the single number of a p-value. But it is one of those things where, due to convention, we have this test. And when you have, hypotheses and you run an inferential statistical test, you get a p-value, and then we either call it statistically significant or not. And so it's sort of taken on this powerful meaning in science, and it is a useful number, but it's just a kind of convention that we have enough confidence to say that we trust there is indeed a relationship between the variables rather than simply having found that connection, that association between the two variables due to random chance. So ethical research means transparency, and it means we should report all results, not just significant ones.